strings of 0 followed by 1 or more digits followed by a dot. That particular VDL can be written more simply by taking advantage of CVDL's macro facility. By defining the macro 0D to represent the sequence of a 0 followed by 1 or more digits, we can rewrite that VDL more simply as shown in the third form, where 0D is specified followed by a dot for each of the octets in the URL. CVDL macros will be covered in more detail a little later in this tutorial. Similar to the \D plus operator, which matches a sequence of 1 or more digits, CVDL has another specialized numeric operator, $#. $# operator specifies matching a sequence of digits while skipping all other characters and only looking at the digits over a default maximum range of 30 bytes of scanned input data. The maximum range of input data to be considered can be optionally specified after the $ and before the string of digits. In the first example, $# and then in quotes a sequence of letters and digits. The code and the subcode words are ignored in that VDL, and only the numerical digits are part of the pattern that's going to be detected. That would match the sequence of digits 1 to 7 in sequence regardless of any intervening non-digit characters over a 30-byte range of scanned input data. The second example shows the optional size of the scanned data being specified as 60, overriding the default of 30. So the sequence of digits 1 to 7 will be matched if they appear in sequence over any 60-byte range of input data. The next CVDL operator to be discussed is the low-level OR operator, which is specified using a vertical bar character. The low-level OR operator will match a pattern at a relative position to the preceding and following patterns. In the example shown, we'll match X followed by A or B followed by Y. So that vertical bar in that case is the low-level OR operator. Do not confuse this OR operator with the high-level OR operator, logical operator, spelled OR, that we discussed in the beginning. With the logical or high-level OR operator, you're combining whole patterns and saying that you want to find this pattern or this other whole pattern anywhere in the file. The low-level OR operator is used together with the concatenation operator to specify alternative patterns at a relative position to the other patterns. An individual byte of data to be matched can be specified using a character in single quotes or using a decimal or hex integer. For example, to match the uppercase letter A, you can just use an uppercase letter A in single quotes, or you could specify it in decimal as the number 65, or in hex as 41. To specify a range of bytes to match, use a dash with the start and end of the range on either side. For example, A-F will match a byte who contains the value anywhere from A to F. To negate a byte or a byte range, the caret or up arrow character is used. So caret 0-10 matches a byte whose value is not in the range 0 to 10. In other words, a byte whose value is in the range 11 to 255. As an alternative and convenient way of specifying ranges for bytes and strings, CVDL includes a fuzzy operator, spelt F-U-Z-Z-Y or abbreviated F-U-Z-Z. For example, fuzzy to 100 means to match a byte whose value is 100 plus or minus 2. The positive and negative offsets can be specified using integers separately or together, as the example shows. Plus minus 2, minus 2, plus 2, all possible different forms that you can imagine are acceptable. And all of them match a byte in the range 98 to 102. In particular, for a string of characters or digits that you want to match with some fuzziness, the fuzzy operator is much more convenient to write rather than writing each character range separately. So for example, the string cal with a fuzziness of -2 plus 3 is equivalent to specifying the pattern A to F, M to R, and U to Z. But it's a lot simpler to write that using the fuzzy operator. Multiple occurrences of bytes, byte ranges, strings, or case-insensitive strings can be specified by putting a repetition number in brackets after the expression. For example, 15 left bracket 20 right bracket will match 20 occurrences of the byte value 15. 0-10 left bracket 40 right bracket specifies a match for a sequence of 40 bytes, each of whose value is in the range 0 to 10. The third example, the string X in quotes followed by 3 in brackets, specifies to match 3 X's in a row. At this point, we've finished covering all of the CVDL operators and move on to a few higher level things related to assisting you in making writing VDLs easier and in using VDLs in general. CVDL includes a macro facility whereby you can define a single word or name to represent a complex pattern. Then when you want to specify that pattern, you simply use the name. The syntax for defining a VDL macro is $define, which must be the first word on a line in your VDL file, and that's followed by the name that you want to give the macro. The name has to start with an upper or lowercase letter or an underscore, and can be followed by 0 more additional letters, underscores, or digits. Then some white space followed by the value. The value continues as a sequence of any characters until the end of the line, and trailing white space in the value is trimmed. So this is very similar to the # define macro facility in C, for example. After defining VDL macros, in order to use them, you just simply specify the name after a $. Macros are lexical tokens, which means they cannot be confused with other tokens such as strings, which means that inside of a string, inside of double quotes, macro replacement is not performed. So for example, $Mac, if Mac is the name of a macro, will be replaced with its value unless it occurs inside of double quotes, inside of a literal string. VDL macros can be nested to unlimited depth, so macros can refer to other macros in their definitions. Macros cannot be used in a VDL before being defined, but they can be used in the definition of other macros before being defined. Macros have per file scope. Macros defined in one VDL file do not carry over to another VDL file. If they did, there would be confusion when you looked at a VDL file. You would not know what macros may have been defined before that file was read. So we restrict macros to the point where they are defined and used only in one file. Here are some examples of defining and using VDL macros. The first example defines a macro named PF1, whose value is $pets and $food. $pets invokes a macro named pets, which has not yet been defined, but that's okay. In the definition of a macro, you can refer to other macros which will get defined later. You just cannot use a macro in a VDL rule before it's defined. The second line defines the macro pets as dog or cat. The third line defines the macro food. Finally, the fourth macro definition defines PF2 as being pets and food macros, but with extra parentheses, which can affect the order of evaluation due to the precedence of the operators. After defining these macros, they can be used in VDLs such as VDL V1, which uses the macro PF1, and VDL2, which uses the macro PF2. Note that PF1, when it's actually used, will be expanded to the complete pattern, dog or cat, and fish or pie. And due to the AND operator having higher precedence than OR, that really is the same as dog, or cat and fish in parentheses, ORed with pie. That might not have been the desired pattern in this case.